I haven't get any questions from you. Does anybody is having any specific questions? Earlier, I think people have asked some questions from random variables, random process, and I think somebody asked from network engineering. So I haven't covered those network engineering questions that we'll try to see today. And I think somebody asked from state space analysis, maybe some other questions people have asked. So you all are like fourth year guys, right? Fourth year are passed out. You can unmute your mic and speak. Fine. Actually, I took some questions from network engineering, from two-port network and transients. Anything else you want? Because that's what I was again and again asking. Based on your requirement, it's better to teach. Fine. So, good evening, everyone. Let us see some questions in today's class from the previous year gate questions. Maybe we'll see some questions from network engineering. And then time permits, we'll see some other questions. So this is the question given in 2022 gate. Consider the circuit shown in the figure. The current I flowing through 10 ohm resistor is, you need to find out the current I flowing through this 10 ohm resistor. This one. Can somebody tell me how to do this? See, actually, we can directly tell the answer for this because always a circuit should be a closed one, then only there will be a flow of current. That the circuit or that loop should be closed one. Here, let us say if the current is going like this, then there should be a return path like this somewhere. Not only this, or somewhere there should be a return path, right? But here, if you see, there is no what to say. Uh, the current is going in this direction, but there is no path to come back for the current. That's why we can simply say current here I is 0. Okay, so if you see here, here it is like, see, current here is 0. It is like open circuit only. Here current is 0. It is like open circuit only. So you can say current in this loop is what? 3 volts by resistance is 1 plus 2, 1 amp. Sorry, excuse me. And in this loop, if you take, also current is 1 amp. But irrespective of that, here the current is 0 because there is no return path for the current to come back. Okay. Let us take another question. Okay, this is from operational amplifiers. So this is the question. For the circuit with an ideal op amp shown in the figure, this is an ideal op amp they have given. V reference is fixed. So this one V reference is fixed. 1 minute. Whether I'm recording. So this V reference is fixed, they have given, and if V out equal to 1 for V in equal to 0.1 volts and V out equal to 6 for V in equal to 1 volts, where V out is measured across RL connected at the output of the op amp. Now the value of RF by RN they are asking. Okay. So in this they have given that the V reference is constant. It's not changing throughout. It is an op amp and ideal op amp they have given. Okay, op amp is ideal. That means it will have infinite impedance, input impedance. And when it is operating in negative feedback or operating in linear region, when the op amp is it operates in two regions, linear and saturation region. When it is operating in linear region, voltage at the inverting non-inverting terminal equal to voltage at inverting terminal, and current drawn at inverting terminal equal to current drawn at non-inverting terminal equal to 0 amps. Okay, op amp is ideal. Then infinite input impedance, that's why current drawn at the both the input terminals is 0. And if it is in the linear region or ideal one, negative feedback always in general, that is in voltage at plus terminal equal to voltage at minus terminal. Okay. Now inputs are applied at the both the inputs. At plus input V reference is applied, at minus input V in is applied. Now we need to find out RF by Rin. Let us say voltage here is Vx. Now what is voltage Vx here? Vx equal to V reference into R2 by R1 plus R2. V reference into R2 by R1 plus R2. This is Vx. And now we can apply superposition theorem. First we consider one source at a time. So first you consider the non-inverting one. So first you consider, sorry, inverting one. V in you consider. The output you say V01. Okay. Now V reference you make it 0. V in you consider and V reference you make it 0. Okay. See here, if you make V reference 0, then Vx is 0. That is okay, right? Now it is an inverting amplifier. For inverting amplifier, we know what is the output. Output is minus Rf by R1 into Vn. This you know very well. Okay. This is for only applying the Vn input. Now suppose the second case what I will take, I will apply V reference input and Vin I will make 0. Now if I apply V reference, you can see here, and if I make Vin is 0, that means this short circuit I am making Vin equal to 0. It is which configuration? This configuration is non-inverting configuration. So non-inverting configuration, you know the output. What is the output? Let us say I am saying that output is V02 1 plus Rf by R1 into Vx, right? What is Vx? Vx is nothing but voltage at the plus terminal. Okay, but what is Vx here? Vx is this one, so I am replacing Vx with V reference into something. So 1 plus Rf by R1 into Vx is R2 by R1 plus R2 into V reference. This is V02. Okay. Now, to what is the output voltage? Total output voltage is individual ones. Add both. So V01 plus V02. So V01 is minus Rf by R1 or Ri into Vin plus 1 plus Rf by R1 into Vx. Just Vx as it is I'm writing. And the question they have given V out equal to 1 for V in equal to zero point 0.1. So first case they have given V in equal to zero point 0.1 if I take, then V out equal to 1 volts. So from this what we get if we substitute, so V out is 1 minus Rf by R1 into Vin. Vin is what? Zero point 0.1, right? Sorry, 0.1 plus 1 plus Rf by R1 into Vx. Okay. Now what is Vx? Vx is this one. But they have said V reference has not changed, right? V reference is fixed. That means Vx also fixed, some constant. The second case what they have given, when V out equal to 6, when V in equal to 1, then V out equal to 6 volts. So same you can substitute. So 6 equal to minus Rf by R1 into 1 volt V input plus 1 plus Rf by R1 into Vx. This will not change because V reference is always constant. So two cases, two equations we got. Let us say this will say equation 1, this will say equation 2. Now we can do subtraction. 2 minus 1, if I do, what will get? 6 minus 1 equal to minus Rf by R1 into 1 minus zero point 0.1 plus these two quantities are same, they'll get cancelled, so 0. So what we get? Rf by R1 equal to 5 by what is this? 5 by minus zero point 0.9 or 50 by 9, that is 9 5 5 5 something. Rf by R1 is 5.55 something. So we can ignore the negative sign here. Always the resistances are positive, right? Even though we are getting negative, only you write the absolute value. So the answer is 5.55. Resistances can't be negative, so the answer is 5.55. Is that okay? Do you have
Yes, sir.
any doubts? Anybody? Fine, we will move on to the next question. This is from DC transients. This is from network engineering. So I give once again a request. So whatever topics you feel difficult, as I said earlier, you can mail me. That will be good because that will be useful. Because now I think past 2 weeks I did not get any questions from the students, so I am selecting some questions and just explaining here. I don't know whether already you know that or it is useful for you or not. That's why my request is you come up with some questions which you feel tough or some concepts which you have which you require some clarification and that is good. Maybe in next class we will do that. Hopefully I'll get some questions or concept topics from you. So this question was given in GATE 2021 ECE for 2 marks. So this is from DC transient. The switch in the circuit is in the position P, where is P, for a long time and then moved on to position Q at t equal to 0. Then the value of dVt of dt at t equal to 0 plus is. So generally DC transients, I think you might have studied, you know better. So time axis, if I take, this is t equal to 0. Let us say at t equal to 0, the switching takes place. Okay. That means sudden voltage applied, some DC, some kind of change in voltage applied. So just a small fraction of time after this we call 0 plus. Just after switching and just before switching 0 minus we'll say. Okay, just after switching, that means you can say 0 plus point not 1 second, something like this. That is 0 plus, and 0 minus means just before switching. Okay, it is like, say, when I'm applying some kind of step voltage, DC voltage, let us say I'm applying DC voltage, step voltage. That means it is like when I'm switching on means a DC, I have connected a DC. Switching on means, let us say at t equal to 0 I'm switching on the power, means before 0, t equal 0, there is no voltage, nothing. Suddenly you are switching on it, that means sudden you're applying some constant voltage. Okay, so this switching action you can model with some kind of step function. Okay, fine. Now what they're telling, initially it is connected to P, and at t equal to 0 it was connected to Q. So for a long time it was connected to P. What does this mean? In this we have two memory elements are there. So one is capacitor and another one is inductor. You know, right, when inductor capacitor connected in in DC circuits and all, what will happen at steady state? So let us say for an inductor, or let us say for a capacitor, I have connected to some DC voltage. Okay, so some DC voltage. Then the capacitor voltage exponentially charges, trying to rise, and at infinity, that means at steady state, it will be equal to what? Voltage source. Capacitor always tries to charge towards the voltage. So this is called transient state. This is called steady state. Now here if you see, switch was connected to P for a long time, and now at t equal to 0 switching action is taking place. That means at t equal to 0 minus, what will happen? The network is in steady state. The network is in steady state. That means what? The capacitor fully charged, and the capacitor is open circuit, that you know, right? For DC, capacitor at steady state acts as open circuit. Similarly, the inductor short circuited, right? At steady state, inductor behaves like a short circuit. So at the so capacitor acts like open circuit, and inductor acts like a short circuit. Hope you know this. At steady state. Now I'm just redrawing the circuit. So I'm just trying to redraw the circuit. 20 volt, 20 ohm, 5 k, 20 volt, kilo ohm. So this is 20 k, and it is connected to P, then 5 ohm, 5 kilo ohm. Now I'm drawing at t equal 0 minus means it is steady state. So what they are telling, see, it was, if this is the time axis, somewhere here we assume somewhere for a long time it is connected to 20 volt source. So somewhere here t equal to, let us say, minus infinity, it is connected. T equal to 0 minus is nothing but steady state for a long time. So the network is in steady state. Now 5k, the capacitor is open circuit. So the capacitor here open circuit. Now let us assume the voltage across capacitor is Vc of 0 minus. At t equal to 0 minus I am drawing, right? And inductor is short circuit. inductor is short circuit. Okay. Now the current through inductor is IL of 0 minus at steady state. This is 10 kilo ohm. Okay. So at steady state in DC, the inductor acts as a short circuit, offers zero resistance, and capacitor acts as open circuit, offers very high resistance or impedance, we can say. Now, can we find out what are the voltages and currents? Now, if you see here, can I convert this into simplification? Anyway, we can do. I can. Sorry. Yeah. And how to solve this? So 5k, 5k. This is 10k in series. Ha. Yeah. Now, if you take this entire thing is a loop, and we can use voltage division principle. You can say the 20 volts is applied across this 5k, 5k, and 10k. Can we say that? Because they are parallel, right? The 20 volts is distributed across 20k. 20 volts is parallel to 20k and also parallel to the other thing 5k, 5k, 10k, right? Now the 20 volts is equally distributed, right? Like according to voltage division principle. Now what is the voltage across this? How much voltage across distributed across this? 5 volts. Across this 5 volts. Across this 10 volts, right? Now what is VC of 0 minus? So open circuit voltage is nothing but 10 volts, right? 10 volts. And what is IL of 0 minus? This current is nothing but 10k by, sorry, 10 volts by 10k. So 1 milliamps. Is that okay? At steady state, the capacitor charges to 10 volts and the inductor current is 1 milliamperes. Till here, is this okay? Fine. Now at t equal to 0 plus, what is happening? Sorry, at t equal to 0, the switching action is taking place. That means this is connected to here and this is open. That means it is a source free circuit. Now if you see here, the source is separated. This will not be there. The source is separated completely from the circuit, and only only the active circuit. So there is no connection between this and this. Now this is one part and other thing is other part. Now at the time of switching, what happened? Suddenly the voltage is changed. Now if it is a resistor, it can accommodate sudden changes. Okay, instantaneously the resistor can accommodate voltage or current changes, but whereas the memory elements like inductor and capacitor, they cannot accommodate the sudden changes. So here what is happening? Till t equal to 0 minus, it was connected to P. That means 20 volt source is connected. Suddenly at t equal to 0, it is connected to Q. That means suddenly the 20 volts got disconnected. So that means switching action took place. So the capacitor and inductor cannot accommodate those changes immediately. So at t equal to 0 plus, what will happen? The capacitor at the time of switching action, the capacitor acts as short circuit and the inductor acts as open circuit. I think you have studied this in your what to say in DC transients. Okay. Now at t equal to 0 plus, or you can say at t equal to 0 at the time of switching action. That means at switching, okay, the capacitor acts as short circuit and inductor acts as open circuit. At steady state, inductor acts as short circuit and capacitor acts as open circuit. At switching time, that is different. Now, I can replace an inductor, sorry, I can replace a capacitor, let us say a capacitor, with something like this. At this time of switching action, I can replace a capacitor uh, with some voltage source, that is nothing but Vc of 0 minus, plus the capacitor is short circuited. Okay, hope you know this. So at the time of switching, that is capacitor is equivalent to C. The capacitor acts as a short circuit at the time of switching, but you remember it is a memory element. It has some stored voltage till t equal to 0 minus. It suddenly cannot discharge, right? It takes some time. The switching action took place, but suddenly the capacitor cannot discharge or charge. So the capacitor acts as a short circuit, but there is a series voltage because we have found out here at steady state capacitor is having some 10 volts. So capacitor in series with the voltage source I can replace. But the capacitor here is short circuited. Here you should have capacitor, but it's short circuited at the time of switching. Similarly, inductor I can replace with an inductor with some parallel current. Okay, but at the time of switching, what happens? The inductor acts as an open circuit. So the inductor acts as open circuit, and the current is, what is the current till IL minus 0, whatever current flowing to the inductors, because inductor current also cannot change suddenly. So 1 milliampere. This is at the switching time. Now with these equivalents, if I replace in this part, what I'll get, I'll see here. Okay. Okay, now I have this is connected to this 5, okay, 5 ohm, 5 kilo ohm. It's connected to P, right? P or Q, something like this. And we instead of capacitor, I can replace this one Vc of 0 minus. That is how much? 10 volts, and capacitor is short circuited. Capacitor is short circuited, and inductor here I think we have some 5 kilo ohm or 10 kilo ohm, and inductor is open circuited, and here we have like 1 milliampere. Now what they're asking is at t equal to 0 plus, now this is equivalent circuit at t equal to 0 plus. This is figure is what? Equivalent circuit at t equal to 0 plus. Fine. Actually, the capacitor voltage cannot change suddenly. So at t equal to 0 plus, at t equal to 0 minus, both are same voltages. Similarly, inductor voltage also cannot change suddenly. So at t equal to 0 minus or 0 plus, current is same. Now what they're asking is dv of t by dt. So this one they're asking. If this is v of t, then they're asking what is dv of t by dt. They're asking at t equal to 0 plus. So what I want, dv of t by dt at t equal to 0 plus. That means what, dv of 0 plus by dt I want. Now for this, what I want actually, uh, capacitor, what is capacitor current? I think we have some relation, right? IC of t is what, C dV by dt, right? For a capacitor, this relation you know, right? Capacitor current I equal to C dV by dt, or capacitor voltage Vc t of dt. Capacitor voltage is at 1 by C integral IC of t dt. Okay. Using this relation, we will try to get this. So what is now IC of 0 plus? This one we need to find out. So this is, let us say, IC of 0 plus. Now the current. Now what is the current? Now what is the current here? So nodal analysis I will do. This is what, 10 volts. Because let us say if this is ground, with respect to ground, it is, since it is short circuit, this is 10 volts. Let us say here is some leaving current. Here IC of 0 minus is leaving current, and here this is the leaving current. Leaving current here is 1 milliamperes. Now from here what I can write, 10 minus 0 by 5k nodal analysis, plus leaving current is IC of 0 plus, plus leaving current is 1 milliamperes, that is equal to 0. So IC of 0 plus is, this is what, 2 milliamperes, is what, minus 3 milliampere. This is IC of 0 plus. Since we know IC of 0 plus from this, what, dVc of 0 plus by dt is what, IC of 0 plus by C, capacitor. So IC of 0 plus is minus 3 milliampere, by capacitor is what, capacitance is how much, 1 millifarad. So capacitance is 1 millifarad. So minus 3 we will get, minus 3 volts per second we will get. So C is the answer, minus 3 volts per second. Is that okay? Have you understood? Basically what they're asking is the voltage across the capacitor just after the switching action they're asking. Just before switching action, you try to find out the steady state voltage and current across the capacitor and inductor. So across the capacitor, what we got, the steady state current, let us say Vc of 0 minus, we got 10 volts. This is nothing but Vc of 0 plus, because within 0 time the capacitor voltage cannot change. Just before switching action, just after switching action, that is same, voltage is same. Similarly, we got IL of 0 minus is how much we got, 1 milliampere. That is same as IL of 0 plus, just after switching action. Now we can replace with their equivalent circuits like this. Instead of capacitor, at the time of switching, the capacitor resists the change in voltage across it, so it acts as a short circuit. So at switching action, you can replace the capacitor with short circuit. If there is an initial voltage across the capacitor, then you have to keep in series, because the capacitor, the switch was connected to P for a long time, so there is an initial voltage as the capacitor that cannot change suddenly. That's why I'm keeping a series voltage here. Let us say if they say in the circuit the initial voltage across the capacitor is zero, then just you replace the capacitor with a short circuit. That's it. No need to write this one. Similarly, inductor acts as an open circuit at the time of switching. There is a parallel current across it. Whatever uh, current flowing through the inductor just before switching, that we will represent in the form of series current. Okay, inductor current means actually the total current is this one, IL of t, something like this. That means initial current plus present current. So till the switching action, what was the current flowing, and now after switching action, what is the current, total current. So that's why I kept in parallel. So open circuit we are and parallel current source. So we are replacing like that, and we want this one. So for that, just you need to find out IC of t, IC of 0 plus. Once you got IC of 0 plus, then we can get IC by C is nothing but the required. Any doubts from this?
Sir, what is the direction of current in capacitor?
It depends whether the capacitor is charging or discharging. It depends. Okay. Now, when the capacitor is charging, let us say we are representing the capacitor voltage like this. When the capacitor is charging from the voltage source, some external source, then the direction of current is this one, capacitor current. It enters at positive and leaves at negative. Let us say it is a source free circuit, the capacitor is discharging. Let us say when the capacitor is discharging, let us say if we assume the capacitor voltage is like this, capacitor discharging means the current flows like this. Here IC of 0 plus is what we got. IC of 0 plus is minus 3 amps we got. We assumed IC of 0 plus is downward direction, right? Here if you say IC of 0 plus is downward direction, I assumed, but I got minus 3 milliamps. That means actual direction is what? Upward, right? Actual direction is 3 milliamperes upward. That means here the current through the capacitor, this is entire capacitor, let us say this is capacitor voltage. Here it is short circuit, and here you have 10 volts. Current is going like this from plus to minus, coming out of plus terminal. That means here the capacitor is discharging. You know, right? In a source free circuit, the capacitor discharges mostly. Since there is no charge, no source, the capacitor property is what? When there is a source, it always try to charge towards the source voltage. When there is no source, it acts as a source. That means it discharges. So here the direction of current is this one, coming out of this upwards. Does it clear your question? Hello?
Yes, sir. Sir, I didn't get the idea of direction.
Still you did not get?
Yes, sir.
No, actually what we got, we applied here KVL, sorry, here nodal KCL we applied, we got IC of 0 plus is minus 3 milliamp, right? Is that okay?
Yes,
That means, see, what we assumed here, we assumed IC of 0 plus is in this direction. After assuming this, after calculating, we got minus 3 milliamps. Minus 3 milliamps downward means what? Plus 3 milliamps upward, right? Yes or no?
yes, sir.
That is the direction of current through the capacitor. Upwards. 3 milliamperes. That's what you're asking, right? What is the direction of current through the
Yes,
capacitor?
sir. Yes.
So that means Actually, this is the capacitor. Let us say from the capacitor, it is from plus terminal. It is coming. Let us say capacitor voltage is this one VC of t. The current is coming out of plus terminal. That means the capacitor here discharging condition. In the previous case, if you take actually the before steady state, definitely the capacitor to the capacitor, the current flows in this direction before steady state. That means before the capacitor acts as an open circuit. In the transient state, the capacitor current goes like this. That means the capacitor is charging. You got it right? Is it
Yes,
okay?
sir.
Okay,
Yes, sir.
fine. Any other questions? Fine. We'll move on to the next question if you don't have any questions. This one you can see this was given in gate 21 for 2 marks. Consider the two-port network shown in the figure. Then the admittance parameters in Siemens, the inverse of ohms is. They're asking admittance parameters. I think you have studied two-port networks. We have different two-port parameters, impedance parameters, Z parameters, admittance parameters, Y parameters, then hybrid parameters, ABCD parameters. Like this, we have different ways of representing a two-port network, right? So, what are the admittance parameter equation? Suppose if you have a two-port network, if you have a two-port network, this is the network, and this is port 1, and this is port 2, and at port 1, this is the voltage, and this is the entering current, and port 2, this is the voltage, and this is the entering current. Then the entire network can be represented in the form of some equations. So what are they? I1 equal to, in terms of V1 and V2, we can represent Y11 V1 plus Y12 V2, and I2 equal to Y21 V1 plus Y22 V2. These are the current equations, right? The y1, y2, this one y11, y22, y12, y121. These are called the admittance parameters. These things, So for this circuit given here, we need to find out the admittance parameters. That means if somehow if we can express this circuit using some KVL or KCL something in this form, we can easily find out the admittance parameters, right? Somehow you try to express that in that way, then we can easily find out the admittance parameters. So let us say here this node voltage is what, this node everything is same. This is short circuit kind of thing. This is same node. What is the voltage here? Let us say this is ground, we assume. What is the voltage here? Here the voltage is nothing but V1, right? With respect to ground, what is the voltage of this node? V1. Similarly, this is V2, let us say. With respect to ground, what is the voltage of this? V2, this one. Okay. Now you can simply apply nodal analysis to get those kind of equation. So at node 1, can I apply nodal equation at node 1? Can somebody tell me at node 1 what we can apply? So here let us say I'm keeping this V1 and here like this, then it will be easy. This is V2. Then at node 1, I1 is entering. Let us say entering current equal to leaving current. Let us say I1 is entering and 3V2 is entering, and let us say leaving current is V1 minus 0 by 1. This one leaving current, this is entering current, this is entering current, and here also leaving current. And another leaving current is V1 minus V2 by 1. Is that okay? Entering current I1 plus entering current, this is 3V2, it's a dependent source, 3V2 equal to leaving current is what? V1 minus 0 by 1 ohm plus what is the leaving current here? V1 minus V2 by 1 ohm. So what we get here, I1 plus 3V2 equal to 2V1 minus V2. What we get, I1 equal to 2V1 minus 4V2. This is one equation. Now at node 2 you apply nodal or KCL here. So this is I1 entering current, here let us say leaving current, let us say here leaving current. Now what is the entering current? I2 is entering current. What is the leaving current? V2 minus 0 by 1. And another leaving current is what? V2 minus V1 by 1. This leaving current. So what we get? V2 I2 equal to minus V1 plus 2V2. So what we got, the equations, I1 equal to first one 2V1 minus 4V2 and I2 equal to what we got, minus V1 plus 2V2 minus V1 plus 2V2. From here Y1 is this one, Y111 is this one. You compare with standard admittance equations. So Y11 is what? Y11 is 2 and Y12 is what? This one minus 4, Y12 is minus 4 and Y21 is what? Minus 1, minus 1 and Y22 is what? 2. 2 minus 4 minus 1 2. 2 minus 4 minus 1 2. Option C is the correct. Is that okay? Fine. Let us move on to the another question. Yeah, this was given in GATE 2020 ECE. This is they're asking the circuit given below. Find the Thevenin's voltage VTH. Uh, this VTH we need to find out. So how to find out? For Thevenin's resistance, actually the resistance, equivalent resistance seen from the load terminal when all the current and voltage sources are deactivated. Thevenin's voltage means the open circuit voltage at the load terminal. So this is the open circuit voltage at the load terminal is nothing but this. So VTH we need to find out. So for this, can we apply source transformation for this? And for this also through source transformation we can apply. Suppose if I have some current source, sorry, if I have some current source and some parallel resistance R, this can be replaced by an equivalent voltage source with some series resistance. The equivalent voltage source is I into R. this hope I guess. So that source transformation only I'll apply here. So you take this, so plus minus 1 volt and 1 ampere, sorry, 1 ohm, and this is 2 volt, 2 ohm, and here what? Again, I can equivalent circuit 4 volts, right? 2 into 2, 4, and 2 ohm, that series resistance, and 4 ohm, this is nothing but VTH. Now, if we see here, when we want to find out the VTH, here it is open circuit. Now that means it is like the 4 ohm is hanging in the air. There will not be any current here, no current here, 0 volts potential drop here, no current here when it is open. So VTH is nothing but voltage across this, voltage between this. Okay, it is like there is no this one here. VTH is nothing but this one. Now in this, let us say assume some current. Okay, now you can apply what to say KVL in this. Let us say I am assume current direction this one. So what is the voltage drops here? This one, right? In this direction, right? In this direction. Now you can apply KVL in this. So 1 into 1 ampere, so minus 1 into 1 ampere, plus to minus from starting from here. Minus to plus I'll take as positive, plus to minus I'll take as negative. So plus 1 volt plus 2 volt minus 2 into I minus 4 volts minus 2 into I equal to 0. KVL applied. So what you get, 5I equal to minus 1. So I equal to minus 1 by 5 amperes. Now what is VTH here? Since the 4 ohm is like a dead one, so VTH is nothing but the voltage across this branch. So 4 volts plus 2 into I, right? 2 into I. 4 volts plus 2 into I is minus 1 by 5. So what we get? 4 minus 2 by 5 is minus zero point 0.4. So 3.6 amperes. Sorry, volts, VTH, 3.6 volts. Hope you don't have any doubts in this. It's a simple question only. Let us move on to the next question. This one you see. So in the given circuit, the two-port network has impedance matrix. They have given impedance matrix. Okay. And the value of ZL for which maximum power is transferred to the load is. So this is the two-port network. For this two-port network, they have given impedance matrix. So impedance matrix means what? It's a Z matrix for two-port network. It is this one, Z11, Z12, Z21, Z22. And just like what we have seen earlier, if it is a two-port network and I1 is the entering current and V1 is the voltage at the port 1, I1 is entering current at port 1, VT is voltage at port 2, I2 is entering current at port 2. So the Z parameter equations are given by this, right? So in terms of V1 and V2, V1 and V2 will expressed in terms of I1 and I2, I1 and I2. So V1 is Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2. Now they have given this Z11, this they have given what? 40, 60, 60, 120. So from this, for this network, we can get like this. So V1 is what? 40 I1 plus 60 I2, and V2 is what? 60 I1 plus 120 I2. Okay. Now what they are asking is the value of ZL for which the maximum power is transferred to the load is. So this is from maximum power transfer theorem. I think already you know this. If you have a source, a network, some network you have, any complex network you have, very complex network you have, and you have some source, everything, and here you have load connected. Now the entire network you represent with its equivalent VTH and RTH. That's it. The entire network I am representing with some VTH and RTH. Okay. You can say VTH is the source, RTH is the source resistance, and you have some ZL, let us say ZTH, I'll say. You know it, when the maximum power is transferred, when the load resistance is equal to the load impedance is equal to the source impedance. Different conditions are there. If it's inductive circuit, capacitor circuit, different conditions are there. But anyway, when the load impedance is equal to the source impedance, then you will have maximum power is transferred. Okay. In the similar way, if I can, how to find out the now Thevenin's equivalent? See, what is the condition? When the maximum power is transferred, the maximum power is transferred when ZL is equal to the ZTH. That means, let us say from here, this entire thing you can represent with some Thevenin's voltage. See, from here, this entire thing I can represent with some Thevenin's voltage VTH, and I can represent with some series Thevenin's resistance ZTH. Then you have ZL. So when ZL equal to ZTH, then only maximum power is transferred. That means from looking from port 2, if I can find out the equivalent resistance or Z output, I can say something. Looking from port 2, if I can find out this, that is nothing but okay, 120 ohm. Now for the entire circuit, looking from maybe 120 might be correct. Looking from here, if I can find out the what to say, uh, the equivalent resistance, then that if that is equal to ZL, then maximum power will be transferred. That means for this circuit, we need to find out the output impedance. We need to find out what output impedance. Got it right? Looking from terminal, so port 2, you need to find out the equivalent output impedance, right? That is nothing but ZTH, right? Thevenin's resistance. And similarly, Thevenin's voltage we can find out, but no need of Thevenin's voltage here, just Thevenin's resistance is enough. So how to find out the Thevenin's resistance? That also you know. You will what to say? You will hmm, deactivate all the sources, voltage source means short circuit and I can place some voltage at the output, and the current drawn is some current, then that is the voltage by current is nothing but output resistance. Let me take here this one. So how you know, hopefully you know how to find out input impedance and output resistance for any circuit. Now this is the circuit. What I am doing is I am just deactivating all the sources. That means this 120 volt I am just short circuiting. Okay, and here I am connecting some voltage source. Some voltage source, let me say V2. Then it is drawing some current, let us say I2. Okay. Some Vx drawing some current Ix. I'm connecting Vx, drawing some current Ix. Instead of Vx, I'm just saying V2. Instead of Ix, I'm just saying I2. Now, this is also we know I2, V2. This is also I2. Now, this ratio, the voltage by current is nothing but the equivalent output impedance, right? Seen from the output terminals, right? Output impedance seen from the output terminals. You got it, right? Okay. Now, how to use those admittance parameters here? Now, here let us say we have V1 and here we have, let us say, I1. We need to get V2 by I2 and we have short circuited here. Is everything okay here? So Z out is nothing but V2 by I2. Now in the input loop, can I write V1 as, see here, since the current is flowing like this, if I apply KVL at input side, what is V1? V1 is nothing but minus 10 into I1. Is that okay? Input side. Already we have these two equations, this one and these two equations we have, and from here we can get V1 equal to minus 10 I1. So using this third equation and first equation, can we get something? 1 and 3 equations, what we can get? You have you understood, right, how I got this third equation? At the input side, current entering is I1 and this is V1. I'm just short circuiting it. Current means voltage here 10 into I1. So what is V1 here? Minus 10 into I1. So first equation, third equation is V1 is minus 10 I1. So equation 1 and 3, what I can get from 1 and 3. Okay. V1 means minus 10 I1 equal to 40 I1 plus 60 I2. So from here, minus 50 I1 equal to 60 I2 implies I1 by I2 equal to minus 6 by 5. Something we got. And actually what way I want to get is this one, V2 by I2 ratio I want to get. That's it. Now from the second equation, second equation, and from, okay, here what I got, 50 I1 equal to this one, right? 50 I1 equal to 60 I2. That means if I can write I1 equal to 6 minus 6 by 5 I2. This, let me say, equation 4. From here only I'm just writing. Now what I want ultimately, the Z output voltage is nothing but V2 by I2. This I want. Now from the second equation, if I eliminate I1, I'll get what I require. So V2 equal to 60 into I1 is what? I can replace with minus 6 by 5 into I2 plus 120 I2. So V2 equal to, this is 5. So 5 12 12 6 minus 72 minus 72 I2 plus 120 I2. So V2 equal to how much? 48 I2. So V2 by I2 is nothing but 48 ohm. This is nothing but our output. That means output resistance. That means this entire circuit I can replace like this. That entire circuit I can replace with some ZTH that we got now 48 volt with some VTH that I did not find out. We can find out VTH how you know, and you have some ZL here. Okay. For maximum power transfer, what is the condition? When ZL equal to ZTH, that is the maximum power will be transferred. When ZL equal to 48 ohm, sorry, 48 ohm, then maximum power will be transferred. So answer is 48 ohm. Is that okay? Does it make sense? Anybody is having any questions? So two Z parameters they have given means it's a two-port network, two equations we can get. And here they're asking for load. What will be the load? See, jet parameter equation they're giving means they're giving one way about the network completely. They're giving complete information about network can be represented in the form of jet parameters or ABCD parameters or Y parameters. So equivalent, the circuit equivalent we have for maximum power transfer when the if entire network you represent with Thevenin's voltage and Thevenin's resistance, and that resistance equal to load resistance, maximum power is transferred. So what I'm doing here is Thevenin's resistance. That means resistance seen from this terminal. So you know the procedure. You connect a voltage, you disconnect the load, you connect a voltage source here. Generally, we do like that, right? For finding output voltage, what we do, the load we will disconnect, right? Instead of load, we'll keep some Vx voltage. Let us say the circuit is drawing some current, and all the current sources you open circuit, all the voltage sources you short circuit. Somehow you try to find out the ratio Vx by Ix. That is nothing but Z output resistance seen from the output terminal. That's what I did. That's it. I connected a voltage source, let's say V2, then V2 by I2 I'm trying to find out. This 120 volt I short circuited. Uh, that's it. Then we got one equation at the input side. Already two equations we have. From this we are just manipulating so that we'll get the ratio V2 by I2. That is what we want. That's it. 48 ohm we got, that is RTH. That is nothing but the load resistance for maximum power transfer. Fine. If you have any doubts, you can ask. Otherwise, we can stop here. Any doubts for anyone? And you can unmute your mics. Are you all guys are fourth year, right? You are attempting gate, right? This side. Sorry, this year. You're giving gate exam, right? Fine. I think we will have one more class, that is this coming Wednesday. Hopefully you will come up with you can mail me with the topics you require and any doubts you have, any concept, anything you can ask from any subject. So if I can do, I will do most of the subjects I can do. So you can ask. Mail ID, sir. Pardon? Mail ID. Oh, I think many times I've given my mail ID. This is my mail ID. Double E w19resh1104@iith.ac.in. You can keep this as subject NPTEL gate topics or doubts, something gate topics, something like this. This you keep as subject and mail me. Try to send. as many as you want. We will cover this Wednesday, so that will be useful for you. Anything you can ask. If I can, hopefully I can do all the subjects except the electronics and all. Still, we'll see. Fine. Then we can stop here. Thank you all. Thank you very much.